Here we're going to look at how to understand equivalent systems of equations, or how to use equivalent systems of equations. The question, what is the solution to the system of equations? And we are given x plus 3y equals 7. Actually, I'm going to write that using black. So x plus 3y equals 7, and 2x plus 2y equals 6. Now, if you noticed from the previous video, if we add or subtract these, neither the x or the y will cancel out. So we do have to find a different process. Now, using equivalent systems of equations, what you're going to do is you want to look to multiply the equations by numbers. You're looking for like terms, or sorry, not like terms. You're looking for the same term, whether addition or subtraction, but the signs aren't going to be terribly important because remember, we can add and we can subtract. Now I'm going to make this a little more involved, just one extra step. There will be a slightly shorter process, but I'll mention that at the end. You'll see. So what you're allowed to do is you're allowed to double or triple or quadruple or times 100 for any equation. So let's say I was to take this first equation and multiply by 2. So that 2 could be distributed in, and I would get 2x plus 6y equals 14. Now these two equations, this one here and this one here, are equivalent equations. If you were to figure out what x and y are, they would be the same. If you were to graph these, you would get the same line on the graph. Okay, they represent the same linear function. So we're allowed to do that 2 times. Now, why would I pick 2? The reason I chose 2 is because I'm taking this value right here. My coefficient in front of the y value. I'm going to use that too. Now you're allowed to do the same thing for your second equation, and this time we're going to use a 3. And the reason I'm going to use a 3 is because I have a 3 in front of my y value there. Now when these are multiplied or distributed in the second equation, I get 6x plus 6y equals 18. And now I want you to notice that our y values match up, so we can subtract and we would be able to eliminate the y values. Now, you can multiply by negatives to change the signs if you wanted to add. You can also only multiply one equation and see what happens there. You might have noticed that by multiplying that first equation by 2, you could have left the second one alone and your x values matched up. But it's going to depend on your level of understanding for these problems. So there will be times where you'll multiply both equations. There is the chance where you only have to multiply one. It's really not going to make it any more difficult by multiplying both of them. It's just one extra step. All right, so let's get back to solving this. So you're going to subtract because the 6's are the same sign, right? These are the same, so we subtract. 2x minus 6x, that will give us negative 4x. 6y minus 6y is eliminated, and 14 minus 18 is negative 4. Divide both sides by negative 4, and x would be equal to 1. All right, now that we know what x is, we're going to substitute. So you can choose, again, any of the 4 equations actually, but I'm going to go with the first one because it looks the easiest. So x plus 3y equals 7, and I'm going to substitute x to be 1. So this x equals 1 is going right here. And then I have 1 plus, that's not the color I wanted. I have 1 plus 3y equals 7. I'm going to subtract 1 and divide by 3. So y would be equal to 2. So my final answer would be 1, 2. Now, one of the things I do want to point out so that you understand it, you see it, and you don't think I'm just making this more complicated for the sake of it making it complicated. If you had the original equation, so that's our answer, we would be done with that problem. But let's say we go back to the original equation here. and instead, this equation you multiply by 2. So you got 2x plus 6y equals 7 like we just did. This equation here can actually stay the same because my x values match up. That won't always be the case, all right? So you won't always be able to multiply one equation. So I tend to have the habit of multiplying both equations. You can eliminate x's or y's, it's up to you. But just keep in mind that it is possible to only multiply one equation. But I wanted to show the more involved process because that's more likely what's going to happen. Most likely you are going to need to multiply both equations. But again, just so you know, it is possible where you'd only have to multiply one equation. If you did that in this example down here, your x's would be eliminated. Okay, so keep that in mind. Just know it is a possibility. That's it. Create equivalent systems and you'll be able to solve these systems of equations using elimination.